5.2. We're going to take a look at how we verify the trigonometric identities. So the main objective is learning how to verify the trigonometric identities. So for example, here we have a term called conditional equations. For example, sine x equals 0, and you know that there is no unique solution. So there's infinitely many solutions out there. So sine 0 equals 0, sine pi equals to 0, sine 2 pi equals 0, 3 pi, 4 pi. So when x equals to n pi, right, it could be negative pi, negative 2 pi, negative 3 pi. So it will cover all the possible solutions. And here, this is what we call the conditional equations, meaning there's no unique solution. And here, when n is integer, then sine x will be equal to 0. Also, if you look at sine x squared plus cosine x squared, we already talked about this, equal to 1. This is what we call identities. And we know that the derivative of this identity could be if you're subtracting cosine x squared from both sides of the equation. Now, this identity is a derivative from the original identity. And this is also what we call an identity. So, utilizing the previous acquired identities, we can derive a lot more identities from there. Okay. So we mainly focus on verifying trigonometric identities, and then there's a very typical procedure about that. So the guidelines or procedures of verifying identities, first step, you work from one side of the equation, and typically you start with the complicated ones. The side with the complicated expressions, usually it's easier to move forward. And I'll explain it a little bit more later. It's often better to work with the more complicated side, right? And then also look for opportunity to factor expression, adding fraction, square binomial, create a monomial denominators. And also always try to use fundamental identities we've been talking about, like reciprocal identities, cofunction identities, quotient identities, and then Pythagorean identities. And if the preceding guideline does not help, then try converting all terms into sine, cosine. That's usually very effective in order to move forward. And if all of the above fails, you can always try something new, right? If you can do anything to move forward, just try that. And sometimes it will lead to a dead end, but it still will give you some idea how to better proceed next time, right? Using a different approach. Okay, and verifying trigonometric identity is a very useful process. Sometimes we need to use a different form of identities in order to benefit the proof or like the problem solving process. And when you verify the identity, you cannot assume that the two sides of the equation are equal, right? You still got to start from the one side. Start from one side of the equation and move to the other side eventually. So as a result, when verifying identity, you cannot use operations such as adding the same identities to each side of the equation or cross multiplication, right? That defeats the purpose of verifying this trigonometric identity, because if you're making assumption they equal to each other. Right, so now let's take a look at example 1, verifying the trigonometric identities. Let's say we have this secant theta squared minus 1 over secant theta squared equals sine theta squared, right? We try to verify the left-hand side or right-hand side. If you look at it, left-hand side is more complicated compared to left-hand side. As you can see, more complicated expression will usually give you a more alternative to proceed. So right here, let's copy the left-hand side. You start with the left-hand side. Since it's a fraction, so I want to divide into that. Secant theta squared over secant theta squared becomes 1. And the other one is 1 over secant theta squared. Now I'm going to flip it a little bit. So it becomes 1 over secant theta times 1 over secant theta, right? Let's split into two fractions. 1 over secant theta equal to cosine, because cosine and secant, they are reciprocals. So 1 over secant theta equal to cosine theta. So now as you can see, this one becomes cosine theta, and the other one also becomes cosine theta. Now you have a 1 minus cosine theta squared. Okay, now we know that sine theta squared plus cosine theta squared equal to 1. Now since we have 1, subtract this, plug in there. So you get sine theta squared plus cosine theta squared minus cosine theta squared. And cancel that, end up with sine theta squared, which is exactly the right hand side, right? Again, this is one way of solving it, but definitely we utilize multiple identities, right? We're using quotient, we use reciprocal identities here. Also, we're using the Pythagorean identity. So be flexible in terms of using all these identities, because you never know which identity could be useful in terms of solving this verified identity. Now let's take a look at the example 2. So now again, we have this identity right here. We try to verify. And if you look at observe both side equation, similarly the left hand side is more complicated. So we start with the left hand side. So we try to simplify from left. And typically we turn everything into sine cosine, right? Because secant x, we know it's 1 over cosine x. Tangent x is sine x over cosine x times sine x. Okay. Now just simplify, so it's 1 over cosine x minus sine x squared over cosine x. Now eventually you become like fractions, keep the denominator, and the numerator is 1 minus sine x squared. And we know that 1 minus sine x squared, so we're using the Pythagorean identities. So 1 minus sine x squared becomes cosine x squared. Okay, and over cosine x. And eventually you end up with cosine x. Now we know that cosine x is the reciprocal of secant x. So it's the same thing as 1 over secant x. Okay. So this strategy works, right? By turning everything into sine cosine, then utilize the Pythagorean identities, and then the reciprocal identities, we verify this particular identity. All right, one more. The last question. Cosecant x squared times tangent x squared minus 1 equal tangent x squared. So right here, again, copy the whole thing, right? Cosecant x squared. Left hand side look more complicated. I'll copy the left hand side. So right here, we're gonna turn everything into sine cosine. So cosecant x squared is 1 over sine x squared times sine x squared over cosine x squared. Okay, minus 1. Okay. Now So we get a 1 square over sine x square. Okay, and this sine x square over cosine x square. And both top and bottom has sine x square, cancel that. Eventually end up with 1 over cosine x square minus 1. And 1 over cosine x square, 1 over cosine x equal to secant x. So 1 over cosine x square becomes secant x square minus 1. So now one more time using Pythagorean identities, tangent x square plus 1 equal to secant x square. Okay, so pack this, plug into that, and over tangent x square, adding 1 minus 1. Now cancel the 1. Now you end up with the tangent x square. Okay, and verify the identity right here. So this is pretty much it. So try to be flexible, utilize the identities you may think of to proceed. And you can basically, the direction is not restricted, so you can try as many ways as you want, and usually you will lead to the correct answer.